In this video I will show you how to add ADC support to your project for the SAMD21 board in Microchip Studio 7. So let's begin. So let's start with the example which uses the USB communication, and first of all let's check if we got the flash offset in the project settings. So linker and memory settings. So we got the flash offset for the bootloader, which we will use. Okay, we can close this one. Okay, ASF, and let's add the ADC in polling mode. Just simple polling, no interrupts needed right now. Okay, apply. Okay. Okay, so it's added. Now let's hop into the driver files of the ADC. And the H file. Okay, so we're looking for this function. Let's just copy this one, the main. So what we need for the function? As in the H file, we have a structure for the ADC module, the instance of the ADC, and configuration. So let's just start with declaring the structure for the ADC module. Let's copy this and put it on the top. And let's name it ADC MD. Okay. Now let's add the structure for the config. Somewhere around here. And let's name it ADC CF. Okay. Fine. Now let's take a look. How do we declare this structure? So we got a function here, which makes the structure as a default setting. So let's copy this function. Let's declare it here. Okay, and let's add pointer to our structure, which we declared here. Okay. Fine, so we got a default structure right here. So now let's go to this function and let's add pointers to our ADC module structure. So ADC MD. And the instance of the ADC is just ADC. Okay, fine. And let's add the pointer to the configuration, which is ADC CF. Okay, fine. Now we need to enable the ADC. So the function is here. So ADC enable. And we got to add the pointer to our structure. So and ADC MD. Okay. So now in the while, we will be reading the ADC. So let's add a function for starting the conversation with the ADC. start conversions. Here we go. So the first argument is the module. So let's put it in. And pointer to the ADC MD. Okay. And now we will read the results. So let's declare a variable which will be uint16, and let's call it results. Okay, fine. And now for the read function, which we got here. So the function will return status busy if the results are not ready, and it will result status OK if we get the results. So let's implement a while loop in which we will continuously read it and check if it's status busy or status OK. So let's copy this. So the first parameter is the pointer to our structure, ADCMD. Okay. And the second one are the results. So the pointer to our results. Okay. And we will check if it's busy. Sorry. Yes. And it was status busy. So let's copy it. Okay. Okay, so we will check if the results are ready. Fine. And after that we will print the results through the USB. So let's delete the printing of 0. Okay, fine. Now let's add a for loop. Oh, we got to sprint the results to ASCII. So let's add a buffer. Okay, and a sprint file function. Let's say the data format is decimal. So now the results. Okay, and now we will print out the buffer. Okay, and in the for loop we will print the chatters. So okay, so let's also, okay, we got the string added. So let's build. Okay, so everything's okay. Now let's flash the program. So now let's put the board into bootloader mode. Okay. Now let's refresh for the port. Okay. File and the offset for the bootloader. And let's write. Okay. We can close this. Okay. And we have to reset the board. So let's do this by just making a short circuit to those pads once. No, 2 times. Sorry. Okay. So now it's in the application. Okay, so we got the port running. And by putting the finger to the pin, we can see it's changing up. Okay, so now let's check the configuration which we can do to the ADC. So we can now close the port and let's go back to the H file, or maybe even let's go here and just search up the config structure. Okay, so that's the configuration you can do. But in the C file, if we go to implementation in the over here. So we got the function for the default configs, and we have the resolution of the ADC set to 12 bits. We can change that to 16, which are implemented by hardware estimation. Okay, so let's do that. So we got by default reading of the pin, which is ADC 0. So let's read multiple pins, and in order to do that, we have a pin scan config over here. So on this module, the pin 0 is actually pin 0 for the module. The pin 1 is not even connected to any pin, and the second pin of the ADC is on the side of the board over here, this pin. So let's add reading of 3 pins. So the offset to start scan we will set to 0, so we will read the positive input, so pin 0, and we will read 3 pins. Okay, so pin 0, 1 and 2. Now let's hop into the main and let's add a few readbacks from the ADC. So let's just copy this, put it here, and we will change up declarations so we don't get errors. Let's just make the buffer as 0 so we can set the 0 variable to something like this, and it will be read as the buffer is completely zero length. Okay, so now we read the second value, and let's add a spacer to it between the results. So over here, Let's add a tab to it. Okay, let's copy the tab over here. Whatever. Now let's copy this again for the third result. Okay, and let's copy this one again. Copy to this. Okay, so we got our three values of pin 0, pin 1 and pin 2 printed. So let's build a project. Okay, so now again let's flash the program. So again, let's put the board into the bootloader. Okay, and as you will select the port, you can notice it will, not in the bootloader. Let's do it again. A little bit tricky because there's no reset button. Okay, now it's correctly. Yeah. Okay, so let's select the port again, and as you do that, you will notice the LED blinking on the port, which indicates it's connected. In this moment, again, set the flash offset, erase all option, and our file. Okay, let's write it down. Okay, close it, and now we will reset it as before. Okay, so we got the board now connected. Let's try it again. Okay, and as you see, we got 3 channels printing. So let's connect the pin of the cable to 0. Okay, and now let's connect the pin to the out of focus. Now we go. So the first pin works fine, and the last pin also. And as you can see, the pin 1 is not even connected to anything. So thanks for watching. See you in the next one.